Increasing Dune Resiliency Through Restoration, presented by Andrea Pickart, Humboldt Bay National Wildlife Refuge. On the California coastline, the native four-dune building grass is Elamis mollis, or American dune grass. It was formerly present along much of the California coast. Elamis is a rhizomatous grass that grows relatively sparsely, allowing sand to move between the beach, the foredune, and the back dune. Elamis may occur as a dominant or mixed with the native dune mat community. Foredunes can also be created in dune mat, which is a herbaceous community of low-growing perennials and annuals. This too was once far more prevalent along our west coast. Invasive Ammophila arenaria, or European beachgrass, was introduced to California in 1896 at San Francisco and is now the dominant species along much of our coastline. Unlike Elamis and dune mat, beachgrass grows very densely, disrupting the flow of sediment and locking it up in steep, narrow foredunes. It spreads into the back dune as well, outcompeting dune mat or stabilizing moving dunes. The Humboldt Coastal Resiliency Project is a 6-year collaborative research project whose goal is to better understand and prepare for climate change in Northern California. It has been funded by the State Coastal Conservancy, BLM, and the Ocean Protection Council. One objective of the project was to carry out a demonstration adaptation site to test the hypothesis that restoration of Ammophila-dominated foredunes to native species increases resiliency to climate change. Further, it hypothesized that species of different morphologies may have different effects. Resiliency here is defined as the ability of the foredune to translate or migrate with sea level rise while retaining its buffering morphology, and the ability of the foredune to recover from storm-induced erosion. This map shows the study site, which consisted of an Ammophila-dominated foredune that was partitioned into 3 treatments and a control. Ammophila was removed from all but the control. Different combinations of species were planted in the 3 treatment areas. This is a picture of the study area prior to Ammophila removal. Ammophila was removed manually. Although this is an expensive method, it is more likely to leave an intact foredune during treatment, as rhizomes and stems are left at the surface to slow wind and erosion. In the Elamis treatment, crews planted Elamis that had been harvested locally at 1 meter spacing. The dune mat treatment utilized locally harvested rootings, here Poemacrantha. Spacing was 1 meter, but every other planting hole was seeded. Dune mat Elamis treatment had Elamis planted at 1 per 4 meters squared, with dune mat species bringing the total to 1 per meter squared. Thus, all treatments had the same density. Almost immediately after planting, we experienced a strong El Niño storm that caused cliffing of the foredune all along the coast. This allowed us to measure recovery, which is resilience, in both control and treated areas. Recovery of foredunes from cliffing or scarping happens through the formation of a scarp fill ramp that eventually reaches the top of the scarp and allows sand to once again reach the crest of the foredune, restoring sediment budgets. As you can see from this series of photos, the control scarp on the left took longer to ramp and heal than the native scarp on the right. Back to our treatments. This series of graphs shows change in vegetation cover and composition by year for each treatment type. The first bar on the left is before Ammophila removal. The solid line indicates the mean cover of dune mat in a reference site. All 3 treatments reached cover goals by 2020. So being shown is the dune mat treatment. This is the dune mat Elamis treatment. And this is the Elamis treatment. Here are some before-after shots from our project. Casual observation shows that we have met our goal of connecting back up the sediment budgets from the beach back to the back dune. Quantitative monitoring was also carried out and is being presented by Dr. Ian Walker in a separate video.